moving on to the end of this arc, at least, Thomas Kuhn can enter again, and he brought history to the center stage of the philosophy of science, and I think marked also a shift in a serious concern for scientific practice, as opposed to more abstract questions about language and theories and relationships to metaphysics. Was history and or were history and practice simply not paid much attention to before Kuhn in philosophy of science?
I think that's a hard question. Again, this is a serious, you're asking a serious historical question. I don't want to be flip in answering it. One of the points that Kuhn makes, which is certainly accurate and was more accurate at the time he made it than it is now because he made it, was that at a certain point, once the sciences become a bit independent of each other and have curricula in the university and have textbooks, that's the main thing, right? When do you move from reading the original text, Newton or Lavoisier or whatever, to reading a textbook that presents Newton and Lavoisier, that those textbooks had a kind of potted history. So you had a sense you understood the history if you read the textbooks. It just turned out that history is just really dreadfully bad, right? And often written from a certain propagandistic point of view. And so you don't really, you think you know the history if you read it, if you get it out of those textbooks, but in fact you don't. Now, I think many people saw that was true. I think textbooks nowadays are probably better than they were back in the late 50s when Kuhn was writing this stuff. So I'm not sure, it would be a little hard to say, did people just not care about history, or did they think they cared about history and thought they understood the history and were just misled, right? They were just mistaken because they were relying on bad history. And so they thought they understood the historical sequence when they really didn't. I think you'd have to look in a lot of detail to answer exactly which of those was going on.
Right. And with regard to detail, I mean, all of the issues that we've touched on so far have books and books written on them. But in the interest of my crammed agenda, I'm asking somewhat broad questions. And here is another one. I mean, his book, speaking of books, The Structure of Scientific Revolutions is widely read. I mean, I read it. I had to read it twice in high school even. But how would you encapsulate, I guess, its main messages for people who haven't read it? It's probably one of the most widely read books in philosophy outside of philosophy.
It is, and I've taught it many times. I think students should read it. It's a tricky book. Just as a little bit of historical background so people understand something, there was this thing, the Encyclopedia of Unified Science, and they had a whole sequence of books, and the books were not supposed to be very long, right? They were supposed to be pretty short, and generally they are. You can go see all the different books that are in the Encyclopedia of Unified Science. And they wanted to have a book on scientific revolutions. The original person they asked to write it was not Thomas Kuhn. Kuhn was a very young guy at the time, right? They asked somebody else, I can't remember who, and that person declined, and then I may have mentioned Kuhn anyway. Kuhn gets the call to write this thing. And Kuhn himself says it was really just a sketch. It wasn't really a completed work. And he intended later in his life to do it properly. I mean, he understood he cut a lot of corners. He understood that all this talk about paradigms was later pointed out. He uses the word there was a claim by Masterson, I think her name was, who found 22 different uses of the word paradigm in the book. And later on he says, okay, get rid of paradigm. Now we've got a disciplinary matrix and we've got exemplars, and he breaks that down. But he sort of always thought of that as a kind of sketch. And he intended to actually write the book properly with enough length and enough depth. And he never finished it. And I think the reason he never finished it, not that he didn't work on it, I think he could never get it to work out, quite honestly. Now, so what is there about the book? Well, one thing is just this observation of a very incorrect presentation of the history of science, which gives you the wrong idea of what science does. And at the time, again, it's better now. At the time, it was this very accretionist view, right? Over time, a scientist discovers a fact, and that gets plunked down into the results of science, and then another one, and then another one, and then they just stack up, right? This kind of way. And it's a very accretionary enterprise. That is what these revolutions give the lie to, because these revolutionary periods are ones where you're not just adding to what came before, but you're knocking down what came before, right? You're to a certain extent rejecting a whole bunch of stuff that had been accepted and replacing it with something else, replacing it with different principles, replacing it sometimes with different explanatory norms, different accounts of what will count as evidence. Everything's up for grabs. And also a bit against, now to bring in the logical empiricists and these people who are trying to kind of put everything in a very rigid, formal structure. The other point he made is that really scientific theories are not axiomatic systems where you can just say, oh, here are the fundamental axioms, and then what are the theorems, right? What follows from that? This idea that to take the notion of a paradigm in the sense of an exemplar, which is one way he uses it, you have a concrete, specific problem that somebody produces what looks like a really compelling solution to. And everybody who looks at it says, yeah, that's a really good proposal there. Now, it turns out that they may not agree. People may agree it was a good proposal, but they may disagree when you start to poke them and ask, but what was so good about it? Or how do I do further work modeled on this? And that was, I think, a correct insight, that when you learn a science, you don't learn a bunch of general principles that you can then turn a crank on some problem and spit out, some solution. And there's disagreements about even what in a successful scientific theory makes it successful. Everything is much more up for grabs than a lot of the presentations seem to suggest. And this, to this day, people just have these cartoony views of science that go one way or another that are just so bad. And it's very important to correct that, because it's just terrible. It's like early on in COVID, okay, they didn't know what was going on. They didn't know the exact nature of that virus. They didn't know exactly how it spread. They didn't know exactly how deadly it would be. They certainly didn't know exactly where it came from. And they were making guesses as they had to. And as time went on and they got better evidence, they would then change their advice. Early on, they would say, look, wash everything down because this virus may be being spread by contact. And then after a while, you say, well, turns out it isn't. It's being spread through the air. You don't have to wash all your groceries when you get home. It's not because they made a mistake. That was the normal course of science. As more evidence comes in, you adjust your views to it. But today, many people have this idea that if a scientist changes their advice, it shows they made an error or what they did was unscientific. It's just the opposite. That's the one thing nice about Popper is this idea of, look, science isn't an accumulation of fact. It's a bunch of conjectures that you put out and you test and you try and knock down. And then you see who survives the knocking down. That's a bit of a cartoon too, in another direction, but it's a better cartoon to start with. Anyway, I'm not even sure what the question, I've forgotten now what the question was I was answering. I think Kuhn helped that, right? I guess, yeah, the question is, what about Kuhn? The first thing is Kuhn started out, he was trained as a physicist, but then he got interested. He was teaching at Harvard, and they had a course in the history of science. And so he was teaching that, which was going back to the original texts and going through them and trying to present them to the students and get the students to understand, what was Franklin thinking about when he was working on electricity? What was Lavoisier doing? What was, Priestley doing, and all these people? And he said it was just very fascinating. Once you get back into the actual historical documents, they're much more complicated than you imagined. And it's healthy to understand the nature of science. It's like that. It's not nearly so cut and dry as a very cartoony view would suggest. And that was healthy. Now, there's a certain point where the structure of scientific revolutions goes off the rails. Somebody, I don't remember who, talks about X-rated chapter X, right? Chapter 10, right around between after 8, you get into 9, 10, 11, 12, things start to go really, really loopy. And Kuhn says things that can be read in an extremely radical way as saying science has nothing to do with the truth and it's all just power. And it's, he makes an analogy, and he makes the analogy of scientific revolutions to political revolutions. And he says, well, at the end of the day, political revolutions are settled by force, not by reasoning. Now, I don't think he meant people to take that and say, oh, I see. Scientific disputes in the end are just settled by force, namely, who has the endowed chairs, and who are the editors in the journals, and they just make a decision and we're going to throw these people out. He didn't mean that, but man, you can read it as if he meant that. Techniques of persuasion, often including force. Techniques of mass persuasion, often including force. He says that's the way political revolutions are settled. And well, it's sort of like that with scientific revolutions. Now, people picked up on the radical one and they went way off. And then he had to try and pull it back. The problem was he never figured out where to pull it back to, because he could never work out a stable position that was both, what can I say, defensible and interesting. Often there's this, there's this two-step that often happens that you can't quite pin down what somebody's saying. Under one reading, it's true, but it's kind of trivial. It's like, yeah, everybody knows that. And under the other reading, it's not at all trivial, but it also seems not at all true. And you can't imagine why anybody would believe it. And if you can vibrate between those two positions in the right way, you can sit there and kind of look like you have this radical view because you vibrate over this way. But then when you're pushed on the reasons for believing it, you vibrate over the other way. And then you say, oh, if that's all you mean, of course, then I can't object, but then it's not very interesting. I think Kuhn ends up in that position, quite honestly. So you can't read the book uniformly. I mean, the first 8 chapters, go for it. Really nice stuff, especially if you haven't ever read any history of science. But 9, 10 to the end, don't, put up your critical faculties there.
Yeah, but I think the disillusionment that he succeeds in espousing with this accretive view of science is the main message and achievement. And the falsity of this accretive view, I find this very interesting. It really contrasts with mathematics, where once something is proven and universally accepted, so not including bad proofs like squaring the circle, it stands. And obviously there are explosions in various directions, like with the discovery of non-Euclidean geometries. But there haven't really been true revolutions like there might be if piano arithmetic or something were discovered and consistent. So even something like Hilbert's program, which in some serious senses is viewed as a failure, like the advances in proof theory and mathematical logic that came out of it remained, even if the conjecture involving a finitary consistency proof of infinitary mathematics wasn't borne out. So it's fascinating to me that there's this serious disanalogy between the development of math and science.
Yeah, but let me take you back to antiquity again for a minute. This is not news to Plato. I mean, Plato was impressed. His whole philosophy sort of falls out of thinking about geometry. You first see it in Meno. And the thing about geometry was that there is such a thing as a proof, right? As a demonstration of a fact. And then when it comes to empirical sciences, if you look at Timaeus, which is where Plato presents as much of physics, as it were, as he ever will do, or chemistry. It's in the mouth of Timaeus, not of Socrates, of course. And Timaeus says at the beginning, look, you shouldn't expect proof here. You should expect at best an ekos logos, which means a plausible story, a likely story, right? If I'm going to tell you about the nature of water and fire and so on, I'm going to come up with something, and it may sound pretty good, but you don't expect me to prove it. We're just not in the realm of proof. The whole world that we only access through our senses, right, the bottom part of the divided line for Plato, you can't have proof there. Exactly, you start to elevate up above that when you learn mathematics, because in mathematics you can prove things. So if someone says, gosh, isn't it amazing that on the one hand, mathematics really is accretive and the empirical sciences are not, you want to say, no, that's not at all surprising, because mathematics works by proof. And once you got a proof, and you can go on to the next one. And science never does. It's always something of a guess.